All right, my name is Aaron. I'm going to be doing the research portion of the presentation for Group 13. Um, we did our project on reverse shell attacks, and some background is basically we have an attacker that wants to have remote access or control some machine. They can have actual administrative uses like performing maintenance on devices that are behind NAT. And they have been used in some actual like attack cases. There was a coin ticker crypto app for Mac OS that had a reverse shell as a backdoor. And then there's also a VMware XE exploit that was developed using a reverse shell. Um, Reverse shells are commonly confused with bind shell attacks. Bind shells are basically where the attacker initiates the connection, and they tend to be really easy to defend with a basic firewall, like one that blocks incoming connections. The three basic steps of a reverse shell attack are step one, gaining access to the victim's device. Step two is payload deployment, and step three is persistent access. Step one is basically going to be deploying through code execution on the target device. This can be remote code execution through open ports like 80 or 443 are pretty common ones. Um, it could also be phishing attempts to download the code. And as I said earlier, there can also be malicious code that are inside applications, um, like the coin ticker example. So from our process, step one would be using Metasploit to develop the exploit code. And this was our aptly named Windows Updater.exe file that was distributed over Apache 2. It can be implemented as an executable that automatically downloads and runs as well. For step two, the code will attempt to establish a connection with the attacker. And it's very important to note that the request comes from the target device. And this means that default or basic firewall configs, like the ones that block incoming connections, will typically not stop this because it's coming from internal. A device inside the network wants to access something outside the network, at least according to the firewall. And in our process, the step two is using Meterpreter, and that's interaction with the target. So that's when we run the listener and the connection will be accepted because the Windows device is requesting the connection with the Kali machine in the demonstration. Step three, now that the attacker has access, they're basically going to want to try to maintain this access, and in a lot of cases, they'll need to be bypassing network filters. This can be done in various ways, so it'll typically either happen through port forwarding, potentially using a proxy server, or tunneling, and then all methods will usually involve encryption to basically hide the fact that these packets are being sent. And in our process, once we get access, bypassing filters is not really applicable to our project, so it doesn't really matter in this context. Some useful notes are reverse shells are often executed over TCP, but it's possible to do them over UDP or ICMP, and they are basically done through various ways. They can be done like Bash, Java, Netcat, Perl, PHP, Python, and Ruby. All of these languages will work to actually deploy one of these. So why would an attacker want to do this? For a specific target, they might want to modify or retrieve data from that specific target. They might also want to inject malware or ransomware on the target device. But also, the target device can be used as a stepping stone. So once they have access to the device on a network, they can attack other devices on the network. They can attack the network specifically. They can try to disrupt availability, or they can try and install more backdoors. So it doesn't necessarily have to be a specifically targeted attack to the final device. They can also kind of bridge to other as well. Um, so prevention, it basically starts at a host space level. We want to strictly manage dependencies and installations. We want to patch regularly. We need to use the best host and container security practices. And this also includes the least privilege access control strategies. Because if, say, we attack a device and the user that we're initiating the reverse shell to doesn't have any administrative access, it's going to be a lot harder to escalate privileges if we are using the correct security practices. Um, and then we want to regularly audit and test software. We also want to disable OS function calls and eval statements when we can in production environments. This makes it harder. And we also want to close all ports when possible. And as I mentioned, especially 80 and 443, because sometimes those are left open. And in our process, Windows security blocks our reverse shell like incredibly easily. I believe he demonstrates that in the end of the video. Most modern software will have basic security that stops basic attacks, such as a basic reverse shell. So turn them on, it'll fix it. Next is going to be monitoring. So if they do happen to get access, these can be detected as anomalous activity over logs. So if you monitor system logs, network traffic logs, command execution logs, if there's anything weird going on, it is going to be pretty obvious to see that. Centralized log monitoring tools are good for this because you can see everything at once. Behavioral analysis tools and RASP tools will be able to detect weird executions going on. At the firewall level, you need something that can manage outgoing traffic as well. Most modern firewalls will have that nowadays. You also want to implement IDS and IPS that is able to detect this anomalous traffic. And then IP whitelisting through firewall for each device is a really good idea. Basically, you can force nodes to only be able to communicate with other specific nodes. And that's going to make it a lot harder for, say, somebody's PC in the office got hit with a reverse shell. Well, if that PC can't reach your important infrastructure at a firewall level, then it's going to be a lot harder for that attacker to actually disrupt that. As for detection methods, like I said, that RASP is going to work really well. There are methods that you can use to detect executables being launched from within containers. This link right here, they basically demonstrate how you can detect a reverse shell being deployed inside a Kubernetes container. And this uses eBPF capabilities, which is implemented in the newer Linux kernels as well. And this is the sources. So now we will pass it over to Isaac to do the actual demonstration of our implementation.
Hey everybody, my name's Isaac and I'll be demonstrating our group's reverse shell. So to start off with, we have two virtual operating systems. We have Windows 11 right here and we have Kali Linux. The networks of both these virtual machines are bridged on my computer. However, if you had two separate devices running similar operating systems, this process would be entirely possible through the router of a network as long as the two devices are discoverable by each other. I would also like to say that the IP addresses you see in this video are perfectly fine to share on screen. I have set them on random addresses independent of their originals. So first we're going to want to open up a new terminal and give ourselves super user privileges. We're going to be using this a lot, so get used to that command right there. Next, we're going to run a command IPA, and what it's going to do is display all the addresses assigned to this network interface. So in this case, it's our operating system connected to Linux. I'm going to quickly record this IP address right here and the port number in a Google Doc. Next, we're going to use Nmap, which is just a network security auditing tool. Using the SS flag initiates a stealth scan with TCP/SYN, which is out of the scope of this video, and the PN flag tells Nmap to skip the ping test and simply scan every target host that we provide, which in this case is just a single run. So we're going to run that command, and we're going to get a list of IP addresses from all of our devices connected to my router on this network. And we're going to look for the Windows IP address, which it looks like it's right here. We're going to record the 192.168.0.165 in that Google Docs that we had earlier. So we're going to be using the SE toolkit. And what it stands for is the Social Engineering Toolkit. It's a set of a bunch of different tools, and it's open source, it's on GitHub. It's really useful for creating these kind of fake attacks on your own devices. So we're going to run that command. It's going to pop up with a cool interface. We're going to want the social engineering attacks, or number 1. Next, we're going to want the create a payload and listener, number 4. And then we're going to want to have number 2, the Windows reverse TCP metinterpreter. This IP address for the payload listener is going to be our Linux address, or 192.168.0.160. The port is going to be 4444. The reason that we're using 4444 is a lot of the times it's already open and port forwarded, on Windows especially. We do not want to start the payload and listener right now. So next we'll be checking the status of our Apache 2 server. Apache 2 is a common open source web server. In our case, it'll be used as the meeting grounds for our 2 operating systems, so they can each have access to a central server in which they can send and receive files. It also has the side benefit of letting us know that our Linux system has reached the Windows system. So we'll now check the status of our Apache 2 server, and as you can see, it is currently inactive. Since it's inactive, we'll just start it up. So we'll open up a new web page and type in our Linux address, and we're going to see if the Apache 2 page is up, and it is. So our SE toolkit created a payload executable earlier and sent it to a .set folder in our root directory. So all we're going to do is copy and rename the payload something that would normally make anyone suspicious, but in our case it's only example. I'm going to use the renaming as Windows Update.exe. And the file is being copied to a directory which our Apache 2 server has access to. This is how we're going to infiltrate our Windows system. So next we're going to go back to our Windows operating system, and we're going to make sure that every bit of security is turned off, because this won't work if it is turned on. So as you can see, my virus and threat protection's off, my account protection's off, my firewall and network protection's off, app and browser control, so on and so forth. This is like the worst case scenario, but since this is such a simple attack, Windows has a bunch of different ways to defend against it, and we need to be able to bypass that. So next, on our Windows computer, we're going to open up that Apache 2 server, and we're going to search for the Windows Update.exe file. And as you can see, it's already giving us a warning that it shouldn't be downloaded, and in reality it really shouldn't. So we're going to keep anyways, and we're going to wait right there. So an interesting thing with this Windows Update.exe file that we've created, this payload listener that we've created, if it was hidden inside of a script in, say, like a virus infested app or anything that you downloaded online, it could run a script in the background and download this file onto your computer without you knowing, which is typically how it would be done, but we're going for simple here, so we didn't go and complicate it at all. So we're going to rerun the SE toolkit command. And as you know, it's 1, enter 4, enter 2. And now we're going to actually run the listener. So on our Windows computer, we're going to run that Windows Update file and start the listener. So we'll go back into our SE toolkit command box, and we're going to actually run the payload now, and it's going to give us a list of a bunch of random stuff, and then it'll show us that Metasploit has finally opened. It'll do a little bit more configuring, and I'll get back to you in a few seconds. Oh, there we are. So in our Metasploit terminal, we're going to run sessions L, and all this is going to do is look at all of our active sessions, and as you can see, we have one with our Windows operating system. Next, we're going to run sessions with the I flag and 1, and what this is going to do is start our interaction with metinterpreter. And next, we just run the shell command, and we are in our Windows shell. So now that we have the shell open, we've demonstrated that the reverse shell actually works. We're going to take it a step farther, and we're going to download a photo from our Windows computer. We're going to navigate to, in this case, I'm the user, but we're going to navigate to the user's files. Next, we're going to do a discovery of what files we have. So after we did that directory search, we found that there's a folder titled important right here. We are going to cd to it, and now we have whatever's in there, so we're going to do another search, and it looks, oh, they have a picture of a dog on there. Would you look at that? So now that we found that important image right there, we're going to exit out of the Windows shell. Next, we're going to cd back into the directory with the secret file, and we're going to download that file, and now we've downloaded it. So it says skipped because I've already downloaded this file, but typically there'd be a line right under here and it would say completed. So if we go back into our file explorer and we search for the download location, there's the image right there. And just to show it, we can go back onto the Windows computer right now and look at our important folder, which should have that file in it, and indeed it does. Our group wanted to do a small demonstration showing what happens if you turn back on the Windows security. So we're going to go back, turn all of our security back on. Okay, that can't be turned on, but that's alright. And we'll now power off and restart. And as you can see, as soon as we got back into Windows, our session died, and with the security on, there's absolutely no way, for this method at least, to access inside of Windows.